So in this experiment, we will see the access control list configuration. So before discussing about the access control list configuration, let us discuss about the access control list concepts. So here we are going to see the purpose of access control list, then wildcard mask, then how do we create an access control list, and then types of IP version 4 access control list. So what is the purpose of access control list? So we are prohibiting the access to a network, okay, for certain packets. Okay, and in order to prohibit, we are going to say some instructions to the router. We are going to create a list of people who can come in, who can go out. Okay, so we are going to create a list. So that is called access control list. So ACL, access control list, is a series of iOS command. So we are going to write a packet filtering command. Okay. And the packet is filtered based on the information available in the header. Right. So that is called as the access control list. So by default, a router do not have any ACL configured. So we have to configure it. We'll use some sequential list of permit or deny statement. So we call that as access control entries. So if you configure a router with access control entries, then you will, when a packet arrives, the router will, so imagine here is a router and you have an ACE database configured for the router, right? So you have a ACE database. So when a packet comes inside a router, the router will check the ACE database. So based on the ACE database, it will either permit or it will deny, right? So that is what happening here in the access control list. So this is to, why do we have to use this access control list? Is sometimes we limit the network traffic to increase the network performance. So we say that we are going to deny certain traffic during the heavy load. Okay, so we provide the traffic flow control. So we say, let us stop the TCP packet for this time. Let us allow the TCP packets. Okay, so you can have basic level of security. We can filter the traffic. So for example, I say that a routing update should not come inside the local area network where it is not in, it does not have any use, right? So you can have screen the host. It provides priority for the packet. So suppose you say at this time only the 3 dot network traffic has to go out, then you can stop the other traffics. So in that way, you can prohibit the access or you can permit the access. So that is what is called the access control list. So the packet filtering usually happened in the layer 3 and the 4, that is in the network layer and the transport layer. So there are two types of access control list. One is the standard access control list, which is based on the layer 3 source IP version 4 address only. Okay, so that takes place based on the source IP version 4 access only. The second one is the extended ACL. So extended ACL takes place, take access, it permits or deny based on some more information like source address, destination address, TCP or UDP. It also uses port number. Okay, so it uses the protocol type also, FTP. Okay, so you can access or you can deny based on more information. That is called extended ACL. So now there are two places where you can create the access control list. One is the inbound ACL and the other one is the outbound ACL. So inbound ACL is when a packet comes inside an input port, immediately the router will check for the ACE, access control entries. So should I need to permit this traffic or I have to deny this traffic? So even before routing table checking, this process happens. Okay, so the router is not overheaded this by using the inbound ACL. So when a packet comes inside, the first thing that happens is it checks the ACE, right? And if it permits, then it checks the routing table on what port it has to put it. This is inbound ACL. And outbound ACL is nothing but initially when a packet comes in, it is checked in the routing table. And if the routing table permits, then it checks the ACE, right? So that is the difference between inbound. So inbound is first it checks the ACE, then the routing table. Here it checks the routing table, it forward to the particular output port, and then only it will check the ACE, right? That's the difference between inbound and outbound. So actually what happens when an access control list, so the router will extract the source IP version 4 address. So, and there is a database of access control entries. So the router starts from the top of the ACL and compare the source IP version 4 address, whether sequentially it will compare whether I have to permit or I have to deny. Okay, so either permitting or denying the traffic. So if the nothing is written about that source IP version 4 address, by default the packet is discarded because implicit deny. Okay, so if there is no entry about that packet, then the router will deny it. Okay, so if you have configured a router to check the access control entries, you should either write a permit or a denied traffic to it because the packet is discarded, right? If you don't have any entries of the source address, the packet is discarded. Okay, now we'll just go for a wildcard mask. So in a access control list, a very important topic is a wildcard mask. So wildcard mask means 0 means match the corresponding bit value. 1 means ignore. Okay, let's see with some example. So 000 means it is match all the octets. So 00063 means the first three octets, match the first three octets and also match the two leftmost bit. Okay, you have to match the two leftmost bits. Here 4 bit. Here you have to match the first three octets and ignore. Okay, 1 means ignore. You have to ignore those 6 bits. Here you have to ignore all the bits. Okay, so that is what is meant by this. We'll see with some example. Let us take, for example, the IP version 4 address 192.168.1.1 and the wildcard mask is 0.0.0.0. Okay, so assume you have created an access control list saying 10, okay, permit 192.168.1.1 0.0.0.0, which means that this access control entry will permit only the IP address 192.168.1.1 because you say 0.0.0.0 means you match 192, 168, 1 and 1. So all the entries has to be matched. Okay. If all the entries are matched, then you permit it. So that is the meaning of this particular example. So let us take this example. Okay. Now here you say that you match 192, 168 and 1. Don't consider this because you say 255. Okay. So don't consider this. So that is what is the meaning of this entry. Okay, so wildcard mask. So you need not consider whatever it is, 2, 3, 4, 5, 6, whatever it is, it will just go above. But strictly it will match 192, 168 and 1. So let us consider the next case. So in this case, it says that 1 into 160 16.0 and the wildcard mask is 0.0.15.255. So now you say that exactly you have to match till this one. Okay, exactly you have to match till this one. So the upper bound will be this 16. Okay, the upper bound will be 16 and then the lower bound will be 0.0.0.0.1 all zeros. Okay, and 0.0.0.1s all ones. So exactly it will find for the match up to this bit. Okay, you cannot change any of these bits, but the other bits you can change. If you change the other bits, you will get this one. Okay, so 0.0.15.255. So the wildcard calculation is a little bit of confusing one. So very easiest method to calculate the wildcard mask is nothing but it is the opposite of the subnet mask. So you might have seen of subnet mask. Okay. So for example, /24 means you will write 255.255.255.0. So its wildcard mask is nothing but 0.0.0.0.255. Okay, where all 0 comes, you put 1. Where all 1 comes, you put 0. You will get the wildcard mask. So opposite of the subnet mask is the wildcard mask, right? And we'll see an example. Suppose 192.168.3.32/28. Okay, 28 means the subnet mask is 255.255.255.240. Okay, 240 is a subnet mask. So let us write the opposite of that. Okay, so the opposite of that is 0.255, opposite 0, 0, 0. Okay, and the opposite of 240 is 15. Okay, so the opposite of 240 is 15. For example, let's say 240, you will write it as 1. I'm writing only the last octet, right? 1, 1, 1, 1, 0, 0, 0, 0. So opposite is 0, 0, 0, 0, 1, 1, 1, 1, which is nothing but 15. Okay, that's the entirely opposite one. You will write it. Similarly, this case as well. Slash 23. Slash 23 means the subnet mask is 255.255.254.0. The opposite is the wildcard mask 0.0.1.255. So if we know the subnet mask, exactly we can arrive at the wildcard mask, which we have to, and which we have to apply for the ACL. There are two keywords. One is the host, the other one is the any. Okay, so the host will substitute for 0.0.0.mask and any substitutes for 255.255.255. Okay, and how do you create an ACL? There are some guidelines for creating ACL. Do not create so many ACL. Okay, so that will be a very congested one. Suppose you feel that a router operates on both IP version 4 and version 6. A router can understand version 4 and version 6. So you can create one IP version 4 ACL on inbound and version 4 on outbound. Similarly, IP version 6, one on inbound and one on outbound. So one ACL, access control list, is okay, right? And so mostly the base, you have to write ACL following the organization security policy. So you have, before writing an access control list, you have to refer the organization security policy, and what you have to do it with the ACL, find it out that, and then take a text editor, first create the ACL, okay, and then you just code it, okay, in the CLI, right? So first you have to code it, okay, in the text editor, and you find out whether your access control list is correct, because intentionally or unintentionally you should not block the genuine traffic. Okay, so that is very, very important. Okay, so what are the four? Standard and extended. So standard means it's done only based on the IP version 4, and extended is based on all. Okay, so more, it consider more. And there is also something called named ACL and numbered ACL. So numbered ACL is 1 to 99 and 1300 to 199 is used for standard. Okay, 100 to 199 and 2000 to 2699 is used for extended ACL. All right. And then named means it will have some name, because number does not have any significance. Okay, say I say ACL 10, whether it is a FTP filter or SMTP filter or what it is, we don't know, right? So here we have created FTP filter. A name is associated with the access control list. So it is very easily. For example, I just put show command, show running, or show start. In the configuration, I'll see the ACL. So with the name, I can understand, oh, it is a ACL for FTP. It is an ACL for TCP. Okay, exactly. We will be able to understand that. Now the question is, where do we place the ACL? All right. So it is better that always the extended ACL should be placed near the source. Okay. So it is good that you place the extended ACL near the source, and the standard ACL can be placed near the destination. Okay. So that is the rule. Please have this rule in mind. Extended ACL near the source and standard ACL near the destination. Okay. So it is very easy for us to do the configuration. Okay. Let us check with this example, standard ACL placement. Right. So example is, there is a network called 192.168.10.0. So you have to prevent this traffic from entering 30.0. So this network traffic should not enter into 30.0. That is a condition. Now there are two cases where you can place the filter. You can place the filter here or you can place the filter here. Suppose I place the filter here. I say filter the traffic 10.0 to all the destination to R. Suppose if I keep the filter here, the 10 dot network may not also go to 31. Okay, so because this router will prohibit all the traffic coming from 10.0. So 31 will not get in, will not be reachable to 10 dot. In that case, it is good that you configure the standard ACL here. Okay, so you can deny the traffic in this port. Okay, so gigabit port. So that is the best solution or the best place to place. So next is extended ACL. So here the problem statement is company A and company B. So company A don't want the telnet and FTP traffic of 11.0 to go to 30.0. Okay, so it don't want. It's an extended ACL. So obviously extended ACL, you will be doing it near the source. Okay, so you can have in S0 1/1 or gigabit 0/0/1. So now if I suppose permit or suppose I deny the traffic FTP and telnet traffic here, okay, in this port, now even the traffic from 10 dot will not go out. Okay, the telnet and FTP traffic of 10 also is blocked. So now if I configure it here, then the FTP and the telnet traffic of this network is blocked. So this is the best place for placing. So when you configure access control list, first you have to consider the organization's policy. That is your problem statement. Next, you have to consider what ACL are you going for, whether you're going for a standard ACL or extended ACL. So standard means only if you go for source IP version 4, you go for standard ACL. If suppose you go for an extended, you can have FTP, telnet protocol based, or you can have TCP based, UDP based. Then you have to think about what access control list you're going for. And then thirdly, where are you going to place it, whether in the inbound or in the outbound? Okay, so based on the requirement, based on your network topology, you have to think about whether it is inbound or next outbound. So now in the next video, we'll see about how to configure the access control list.